Hi, this is Kevin. Welcome to part two of my lecture on chapter five of the Zelle third edition Python book. If you haven't played the part one lecture, then please go do that and come back here. So here we're going to begin to talking about formatting. Okay. So up until now, I guess we've done a little bit of formatting by creating a string out of parts. Okay, so we've used concatenation to concatenate various string parts to create a whole string. And then we've been able to print that, and that's kind of formatted. Now, what if we wanted to print something that was what if we wanted to format something that was a little more challenging? Okay. So for instance, what if we had the date uh, 05/24/2015 in this month, day, year format, and we wanted to convert it to May 24th, a comma, space 2015, period. Okay, let's say it's at the end of a sentence. Okay, now, first of all, uh, what's the best way to convert a date from one format to another format? Is it to write your own code? I'm going to say it's not. Oh, okay. The best way to do it is to find one of the Python packages that will do this for you. And the two I'm thinking of now are the date time package and the calendar package. And they both would do this, and you'd have to learn how to create an instance of their custom class, and you'd have to call some methods or some functions, and you would have your beautiful answer. Okay. Now, uh, if I had to go do that now, then we wouldn't have the opportunity to learn how to deal with some of these formatting, uh, kind of edge cases, the harder cases. Oh, okay. So we're not going to use the date time package or the calendar package. Uh, Even though if you were doing this on your day job, that's probably what you do. You go learn about them and you do it the easy way. All right. So we have a program here. Okay. And we're not quite into the program code. This looks like pseudocode. So we're going to input the date. We're going to put it into a variable date string. That's not well named in Python terms. We're going to split the date string into month, day, and year strings. Okay, we can do that using split. Convert the month string into a month number. Okay. Use the month number to look up the month name. Create a new date string of the form month, day, year. Output the new date string. Okay. And they're kind of showing us how to do this. And let's see if we can get to where we are. So there's a program that came with the textbook called Date Convert. And it looks like this is the code that he's showing us a part of on the slide. Okay? And like all the rest of the programs, it can use some cleaning up. It needs a doc string. Some of the variable names are not well-formed Python variable names. They're probably not well-chosen names. And we've got more comments than we need for a program that we do in our day job as compared to a program that an instructor wants to talk you through. So I've refactored it to date convert refactored. And here's how it looks when it's refactored. Okay, less busy. Okay, so we've got a doc string. So then we prompt the user for a date string. Remember, we don't have to further convert it because it's a string and we need a string now. And now here's what we're going to do. We're going to call split on the date string, and we pass it as a parameter. We pass the /. Okay, so that it tells split that the separator character is going to be the /. Okay, and what does this throw off? Well, it throws off a list with the 3 parts of the date. Okay, are we going to access this list as a list? No, we're not. We're going to immediately unpack the list into 3 regular variables. Sometimes computer scientists call these individual variables scalars or scalar variables. And we're using a better name, I think, than was in the original program: month string, day string, year string. Okay. It is common to do a split, and if you know how many items are going to come from the split, to just unpack them right on the same line. It's a good practice. Now we're going to have a list that holds the full names of all of the months. And months 0 is going to be January, and months 11 is going to be December. Okay. And here's what we do. We say that month string gets assigned the value months. So we're going to get one of the items in the list, months. And we're going to take int of the month string that we got back. Okay, we're going to turn that into an int and subtract 1 because we're off by 1. January is month 1, but it's index 0. Okay, so we've retrieved that into month string. Okay, and then we print the converted date is month string, comma, day string, plus a comma, year string. So let's look at this. Let's say January 1st, 2023. So January 1, 2023, it worked pretty well. Okay. So we really haven't gotten into anything too challenging here, right? And the reason is this. Everything that we're trying to concatenate is a string. Okay? So if we want to concatenate the day string and a comma, we can just use the plus operator because they're both strings. No problem. We're going to see in a minute or two if you want to do something more challenging, well, then you're going to have to do some extra work. So let's look at date convert to. Okay. And date convert to, oh, that's not, that's what I did with the date convert. So not a problem there. I'm not going to show you that one. Let's go back to the slides. Sorry about that. Okay. Now, you do get into a problem when you want to format output and you want to have a number and then you want to concatenate it with some string character. Okay, so here, for instance, um, we want to print the value is, and then there's a comma, so we get a space, string of value plus a period. Okay, so that's how we can end the sentence with a period. Okay, now what if we just put value there? It turns out that doesn't work because we have we have a variable that's a number type, and we have a literal that's a string type, and there isn't a defined version of the plus operator that combines a number and a string. There's one for a number, and a number, it does addition. There's one for a string and a string, and that does concatenation. So what we need to do if we want to do this kind of formatting is convert the number to a string, and we do that by calling the stir or string function. Okay? That's how we get that done. Now, is that how we typically do it today? Today, we typically use these things called F strings, which we're not going to get to till we get done with the normal lecture and into the supplementary material. But you'll find a lot of code like this around that predates F strings. So you have to kind of understand, why are they turning this, why are they trying to turn this number type into a string while they're doing it, so they can concatenate it with this string that is a period. And a typical use case for this is you want to print out a user-friendly sentence, and the last thing in the sentence is some kind of a number value, and you want to follow it by a period, and you have to use this trick. Okay? Yeah, oh, this is good. If we hadn't called string, we would have gotten a type error. Okay? So it says if we try to use the plus operand for a float and a string, it doesn't know what to do. So now that we've seen that we can convert a number type to a string, we've seen that there are, the author would say that there are 4 ways to convert values. And I'm going to say that eval has been fully discredited. Okay, so I'm going to want you to forget eval. So the 3 that we have are float, which turns a string into a float, int, which can turn a string into an int, string, which can turn either of the number types into a string, and not eval because we're not putting that into our programs. Okay. All right. So let's try to do some more formatting stuff. So we're working our way up to a new program, which is going to count up change. And I think this might have been a program that we started some version of in chapter 3. So now here we are. And this is a change counter program, and it prompts us for the quantity of quarters, dimes, nickels, and pennies, and it shows us the total value of your change is 1.5. And we're asking the question, shouldn't it look more like $1.50? Well, with some formatting tricks, we can make it read like $1.50. Okay, so here's what we do. We have a string. Okay, this is what's called a formatting string, this one right here. All right, you can tell he's using the double quotes. Okay, And you'll notice that the formatting string includes some kind of pretty things like sentence words, but then we've got this kind of text at the end, okay, and that's, well, it's it's a dollar sign, and then we've got these formatting characters, okay, and interestingly, then we call the method format on the string, and then what do we pass in? Well, this group of characters uh, are placeholders. Okay, so what this says, so 0, this is a number of the placeholder. So this is going to be the first value that's going to appear in the list of parameters. So the reason that we know that total is going to be formatted into this placeholder text is that total is the first parameter, which of course has index number 0. Okay, so that's just how we know which one. Then we have a colon, and then we have this thing called a formatting string. So 0 is a, oddly enough, it's the width. If you give a width more than 0, like 1 or 5 or 35, that's the width it makes the field that it prints. If you give it a 0, it says, I want you to take all the space you need to print the information that's in the variable. So 0 says, take the space that you need. The decimal point is put a decimal point here, and 2F says I want a fixed 2 decimal points to the right, 2 decimal digits to the right of the decimal point. So because of that, it says the total value of your change is 150. Okay. Now, is this the way that everybody does it these days? No. When I get to the supplemental material, you're going to find out that a lot of people are doing this with formatting strings, F strings. The format specifiers, though, are the same. Okay, so this 0.2F, this is kind of a formatting language that works across. Python has 3 or 4, it's actually got 4 formatting approaches. This one that we're seeing here, where we call a format, that's the third of the approaches that were used in Python. And so it was the newest one available when this text was written. But the newest one now, after Python 3.7, is F strings. And we'll get to that in due time. So let's see. So we're going to have a template string. Then we're going to call .format on it, and then we're going to have values. Okay. Within the template string, these curlies mark slots or placeholders in which the values are inserted. Each slot has a description that includes a format specifier that was like that 0.2F. Okay. The template that we saw contains a single slot with the description. Again, this is the index. This is how you know how to match it up with which parameter. And this is the format specifier. This is the format specifier right here. Okay. The F means fixed point. Okay. The width, that's what comes, that's the 0.2F. And so the 0 says use as much space as you need. Uh, the precision is the number of digits to the right of the decimal point. That's the 2. And the F said it's fixed. And here the author gives us some examples of how we would format using uh, the format method. And again, there have been 4 approaches historically to formatting with Python. Calling the format method is the 3rd, so it's not the most recent, but it's pretty recent. Numeric values are right justified and strings are left justified by default. You can also specify a justification character before the width. So if you want it to be 5 characters wide and left justified, you would say less than 5. If you wanted it to be 5 characters wide and right justified, you'd say greater than 5. If you wanted it to be centered in 5 characters, you would say circumflex 5. So now it's time for us to write a better change counter. Okay. So there's a couple things that we want to do. We want to make sure we have the right formatting. But an issue is raised here of whenever we're using floats in order to represent dollars and cents, okay, we're usually okay if the amounts are not that big, okay, because floats are implemented as double precision floating point numbers, and they have a fair amount of digits of precision. And so the only problem that we have is we have these rounding anomalies that we get that are the result of these things being expressed in binary. So the fractional part of a number is a binary fraction. So what some people do is they decide for money to just keep everything in pennies, and pennies can be integers, and integers can be infinitely large. So that's one solution to the fact that using floats for dollars and cents can get you some cent rounding problems as soon as you start getting very large amounts of money. Okay. One solution is to do your math in pennies and then format it. Okay. Another one is to use the Python decimal class, and quite a few organizations do that. The Python decimal class is beyond the scope of our course, but it's something that you might be interested in looking up. So let's find this better change counter. This is called change 2. And let me bring it over here. So this is change 2. And again, change 2 has got some kind of problems. Okay. And so I created a change 2 refactored. I didn't want to do that. Okay. Change 2 refactored, which has a nice doc string, parentheses around the calculations to make it easier to read, those kinds of things. Okay. And then I think I clean this out a bit. Okay. So if we go back and see, remember that one that ended in $1.50 and we only got 1.5? That's a while back, but let's find that. Yeah, here. So we had 6000 and we got 1.5. So let's come back here and run this better version. And let's do 6000. We get $1.50. Now, how do we do that? Well, here we use the count the pennies approach. Okay, so we have quarters times 25, dimes times 10, nickels times 5 plus pennies. Okay, oh, well, I think we went nickels times 5 right there, plus total equal. Oh, I hate it when I do this. I think we just want to do that. Yeah, we had an extra close parenthesis. Okay, so now that's really cleaned up. So let's test it again. 6000 $1.50. So how did we do this? Well, when we go to print, we have this, kind of template string, okay, which has all of our words. It has a $sign. That's kind of part of our words. And then we have a we're saying that the first value, which is index 0, okay, that's going to be the first parameter. We say that's going to be this. So that's going to be total integer divided by 100. So that's going to give us the whole dollars. Okay, and then we have a period for the decimal point. And then index 1, that's the second of these. This is going to be total modulo 100, so that's going to get the remainder of the pennies. And then we're going to say it can be as wide as it needs to be. And we want to right justify it in 2 spaces with the with two characters of precision, I guess is what we're really saying. So when we do that, we get $1.50. Okay, now again, for the time the book was written, this was the best formatting to be done here. And there's plenty of code that you'll inherit that has exactly this kind of formatting. Okay, before we're done, we're going to be using all F strings. Okay, we won't be using this. But interestingly, the language about how to format these things, these format specifiers, they're the same against all 4 of the Python formatting schemes. The rest of the syntax is different, but the format specifier language is universal. Okay, so that's what we're doing there. So let's get back to where we were when we brought up this change counter. Okay, so that was the change counter, the better change counter, which was actually called change 2, and my version, which I showed you, was change 2 refactored. So now we finally got into files. Okay. We say a file is a sequence of data that is stored in secondary memory, a disk drive, a solid state drive. Files can contain any data type, but the easiest to work with are text. Okay, so most of the files that we use, and I think all the files that we're going to be using in my class, are all text files. So any values that were numbers inside the program have been converted to text before they've been written out to the file, and then when we read them in, we have to convert them back to numbers. The file usually contains more than one line of text. Python uses the standard new line character to mark the line breaks. Okay, now before we leave slide E4, I just want to point out that a file is a sequence of data in the vernacular sense, but a file is not a Python sequence type. That has a special meaning, and strings are Python sequences, and lists are Python sequences, but files are not. Okay. What strings and files and lists have in common is they're all iterables. And so we can use them with the for in construct. Okay. So multi-line strings, hello world, goodbye 32. I guess what we're saying here is that we can have this text, okay, which in a text editor, or if we printed it, would come out on multiple lines. But when we store it in a file, it's just one way to look at the file is just one long string of text, okay? And wherever there would be a line break, we just have a new line character, okay? This is exactly the same thing as embedding the new line character in print statements. Now, remember, these special characters only affect things when printed. They don't actually do anything during evaluation. And again, evaluation sounds like eval. Most of the things that we want to do with strings that come in from files and consoles, we don't have to worry about the fact that there's a new line at the end of the line. So if we are getting a string in, okay, and it's coming in from a file and it has a new line on the end of it, and we want to call int is robust enough that it doesn't worry about the new line, okay? If we want to call float, because it's a floating point number, float isn't bothered by the fact that there's a new line. That's why he says they don't do anything during evaluation. We do have some situations, though, where we're reading in a string from a file, and we have the new line. If we turn around and we print that, we're going to find out that it had a new line on the end of it. So there are times when we're trying to get our line spacing just exactly right, that we have to remember that something that we read from a file that was at the end of the line has a new line at the end of it. Okay? File processing. Okay, so the process of opening a file involves associating a file on disk with an object in memory. Okay? We can manipulate the file by manipulating this object. So we read from the file, we write to the file. And when you see some code here in a second or two, it'll be a little bit clearer. When we're done with the file, it needs to be closed. Closing the file causes any outstanding operations and other bookkeeping for the file to be completed. In some cases, not properly closing a file could result in data loss. Well, why is that? Well, it turns out that reading and writing files are pretty slow operations for our programs. Okay? And our programs, which you'll see in a minute or two, are written as though we're actually going to read one line at a time. So we're going to read a line, we're going to process it, we're going to read another line, we're going to process it. And then when we write a file, we do the same thing. We print a line, then we come back, we print another line, then we come back, we print another line. Now, is that how Python interacts with the disk drive? It really doesn't. There's an approach to speed up file processing called buffering, in which when we're reading an input file, the first time that we issue a read, kind of under the covers, Python causes the operating system to go out and read a bunch of lines, okay? And those lines are kept in a kind of holding area called a buffer. And then every time we ask for one, instead of having to read from the disk, it just takes one out of the buffer. Eventually, we ask for one it doesn't have yet, and it reads another block of lines, and it fills up the buffer again. Likewise, when we say we want to print a line to a file, does it really print it to the file exactly when we say it does? No, what really happens is when we open the file, we create a buffer area. So the first time we print, it just puts it in the buffer. And then the next time we print, it puts it in the buffer. And the size of the buffer is something that we don't typically control. But let's say it might hold 25 lines. Well, it wouldn't be till we printed the 26th line that the operating system would actually print those 25 lines in the buffer out to the file. So here's how you can lose data. Okay. When you close files, output files, any lines that are in the buffer are flushed out and written to the disk. Okay. If you don't close a file, they might not be written. Okay. Forgetting to close an input file won't cause data to be lost. But it's considered kind of impolite and a bad form, okay? And we'll talk a little bit more about that as we go through the course. Now, we read and write files all the time in a word processor, right? So, let's say that we open a Microsoft Word document. We double click on the document and it fires up the word processor of Microsoft Word, and the file is open. It reads the contents into RAM, into the memory. It closes the file. We make whatever changes that we want to make to the document. The document as it exists on the disk is not changed at that point. Okay. And then when we're done with our changes, then we tell the program that we want to save. Okay. And at that point, the original file on the disk is reopened in a mode that will allow for writing. This actually erases the old contents. And then file writing operations copy the new version of the document that's in the memory out to the disk, and then the file is closed. Okay, so We do reading and writing of files all the time when we use a word processor or a spreadsheet program, and we don't even really think of it that much. Now we're going to learn how to write a Python a program that does this much more explicitly. Working with text files in Python, uh, we associate the disk file with a file object uh, using the open function. So we have a variable name that's going to hold the file object, and we call open, and the name of the file that we want to open, actually the full path to the file that we want to open, and the mode that we want to open it in, read or write. So we might call the file in file. A lot of times input files are called in file and output files are called out file. It's kind of a Python tradition. And then we call open and we pass it the name of the file. That's in our current directory. If it's in another directory, we have to precede the name with the path to the directory that holds the file. And then we have a mode, in this case, R for read. Once we have a file open, we read the file by calling methods on the file object. So if we call the read method, it's going to return the entire remaining contents of the file as a single, possibly large, multi-line string. Okay. What if we wanted to read a line at a time? Well, there is a method we can call readLine, which just returns the next line of the file. This is all the text up to and including the next new line character. So the new line is always at the end of what you read. And last, we could create read lines. Okay, we could call read lines. It reads the entire file and it creates a list of character strings, one for each line of the file. Okay. And depending upon how we would want to read a file, we might use one of these. Or we could use the construct for line in file, so we could iterate over it using for in, and that's going to be the more typical thing that we're going to do. Okay. So here's a real simple program called print file. And instead of looking at it on the slide, I'm going to bring over PyCharm. If I can get PyCharm to listen, here it is. Okay. So, print file. So this is print file. And again, it's got some of the usual problems that we get with the programs from the book. So let's look at the refactored one. Okay. Now we've got a nice pretty doc string. Okay. I've kind of improved the variable names so they're a little bit more standard. Okay. So we prompt the user for the name of the file name. Okay. And then we say we get a reference to the in file object by calling open with the file name, the mode, which is a character string R, and then the other thing that we typically do that they don't address in the book is that we want to control the encoding of these documents. So when we read them or we write them, we're going to have this keyword parameter encoding equals UTF-8. Okay, that's the standard encoding for documents in the US. And then what we're going to do is we're going to use the read method in order to read the entire file into one big string object. And I changed the variable name to call it entire file contents. Okay. And then we're just going to turn around and we're going to print entire file contents. Now, right now, we're printing it out to the console. Okay. So let's look at this. Let's try to give this a run. Okay. So we're going to run print file refactored. And he has a file here called names.txt. So let's do names.txt. And it prints the 3 names. Okay, so this is the file right here, including the new lines. Okay, so one kind of interesting thing, if we want to read a file and print the whole thing, we can do it with one read and one print. Okay, not typically the use case that we have, but we can do it. Okay. Now, readline can be used to read the next line from a file, including the trailing new line character. Okay. Now, this is interesting code. A couple things going here. So we opened some file. Okay, that would be a file name with the method with the mode R for read. We don't have the encoding here because that's not really covered in the book, but it's something that we want to do in our class. Okay, so now we say for I in range 5. So this is going to run this loop 5 times. Okay, and we're going to call read line on in file. So that's going to read a line, the next line. We're going to put that in the line, and then we're going to print the line. Okay. And what's interesting here, you see a slice expression here. We want to start at the beginning, okay? And this -1 says that the first one that we don't want is the last character. Why is that? The last character is the new line from the file. If we did a print, and we did the last character, then the problem that we would have would be we would get double spacing on the lines. Now, I also want to point out that this is kind of brave because in a typical file, we don't know how many lines are in it. It could be empty. Okay, so just redlining 5 times is a fairly daring thing to do. If there aren't 5 lines there, it's going to blow up. Another way to loop to the contents of a file is to read it in with read lines and then loop through the resulting list. Now this is, it's easy to get confused here, right? So, in file, a typical file name for the input file. So we open it. Again, we didn't set the encoding, but it's not really being covered in the text. So now we say for line in, and we're not saying for line in file, okay? We're saying line in file read lines. What do we get when we call in file read lines? We get back a list with all the lines in it. So here we're saying for line in list, okay, this is a list. What's the name of the list? Well, it doesn't have a name. Because we did this, kind of in line, this is a list that doesn't have a variable name. It's like an anonymous list. okay? And then we would process each of the lines in the list, and then we could close the file, okay? So that's another way to process the file, okay? Now, on slide number 96 here, this is the classic way that we read a file, okay? Unless we have other considerations, we use the for in construct. So we open the file, okay, and then we've associated with the file name, with the file object named infile, okay. So then we say for line in infile, we process one line right here. That's what the comment says, and then when we're done, we close. I often will put a blank line after the loop and before the close, just to remind the reader that the close is not part of the loop. We definitely don't want to be closing the file every time we go around the loop. In fact, this is a problem that happens to new programmers quite a bit. What about writing files? Well, it's kind of symmetrical, right? So here we create, this is the variable that's going to hold the output file object, and it's called outfile, and that's kind of a traditional Python name for an output file object. And so we open, again, we have the file name. It could be preceded by a path if it's not in our directory. We have the mode, which is W for write, and in my class we add the encoding equal UTF-8. And now, how do we print to this? Well, we just do a normal print. So we say print, and then we have some expressions. This is what's going to get printed. How do we get it to go to the out file instead of to the console? Well, we just have a keyword parameter here, file equal out file, and it gets printed to the out file. It's really that simple. It's beautiful. Okay, so this gives us the opportunity to do a number of things. Okay. One thing it gives us the opportunity to do is to take some kind of action that we would have done one of previously and do it again and again. Okay. So let's look at some program that we would have done one of. There's one in the directory for this chapter called username. Okay, and I'll bring that over on PyCharm so you can see it. So this is username, and again, this is the version that comes with the text. And what I'm going to do is I'm going to open up username refactored, which of course I wrote. Okay, so what is, and I think we looked at this already in part one. This is simple string processing program to generate usernames. So we prompt a user for the first name in all lowercase and the last name in all lowercase. And then we form the username through indexing and slicing and concatenation. And then we print out the username. Okay, so that's how we would do one. What if instead of prompting the user for these one at a time, we wanted to read in a file of names, okay, and then we wanted to print out a file of usernames? So along comes user file, okay, and I'll just show you that we come to user file, okay. Okay, so let's look at user file. So user file, again, has got all the normal problems with variable names and comments and stuff. And so I've created user file refactored. Okay. Uh, and here's what this looks like. Okay. We've got a doc string programmed to create a file of usernames in batch mode. Okay, so we print a string that says that we're starting the program, and we prompt the user for the file name. Okay, and then we prompt the user for the in file name. We prompt the user for the out file name, and then we create the in file object by saying open in file name read encoding UTF-8. And then we create the out file object by open out file name write mode encoding UTF-8. So now we have the input file and output file open. Okay. And now we can just go through the file. So this approach is called batch mode. Why is it a batch? Well, it's a batch of input transactions. Okay, this has been called batch processing for 60 years, 70 years. It may have been called batch processing even before we were doing it with modern computers. So this batch is an old adjective, batch processing. So we're going to read a batch of requests on the in file, and then we're going to print usernames to the out file. So how do we read the input file? Well, the classic way for line and in file, we're going to get a line at a time. Okay, we're going to split the line and unpack it immediately. First name, last name. Okay. And then we're going to form the username by taking the index of the first character. So we're going to take the first character of the first name and the last 7 of the last name. And we're going to take that expression that's surrounded by paren, and we're going to call lower on it. So we're going to get a string out of that expression we're going to call lower. Okay. In the first version of this, the single version, we ask the user to type them in a lowercase. With the names that we're going to use, they're in mixed case. That's why we need to call lower. Okay, and then we're just going to print the username, which we created, and we're just going to say file equals out file. And then when we've gone through the in file and processed all the records, then we can close the in file, close the out file, and we're going to print usernames have been written to out file name. And I just want to point out that this print, unlike these are going to the file, the output file. Because it doesn't have a file equals out file, it's being written to the console. So let's give it a run. Okay. So we've got that. What file are the names in? Well, we've got a names.txt. Okay. What file should the usernames go in? Well, let's call it usernames.txt. Okay, and then let's open usernames.txt. And the names were John Zelle, Zaphide, Beeblebrox, and Guido van Rossum. Guido van Rossum is the kind of developer of Python. So these are the 3, and then we turn them into usernames. We can see that we got what we wanted. So this is typical batch processing. You can take, kind of any transaction-oriented work or transformation, and you can take one that you would prompt the user for input one at a time, and then give the answer back in the console one at a time. You can take it and uh, put all the input into a file, and then you can put all the outputs into another file, and you can uh, wrap the same kind of processing that you were doing when you were doing this for just one. Okay, so this I would call the batch design pattern. Okay, I'm not sure we actually say that in the book, but that's what we mean. Okay, and he's got some pseudocode and things to note. It's not unusual for programs to have multiple files open for reading and writing at the same time. We just saw how that works well. And then the lower is used to convert the names to all lowercase in the event that the names are mixed upper and lowercase, which they were. Okay, so the rest of this chapter and the rest of the slides are dedicated to a uh, they're dedicated to a feature that I no longer cover, and that's these file dialogues. Okay, um, when we're selecting files, when we're working with the user at the console, if we want to choose a particular directory, we ask the user to type the path for that directory in. If we want to use a particular file name, we ask the user to type the file name in, and then we build the path and file name, and that's the string that we use when we open. It's possible to do this using a graphical user interface called, I used to call it tkinter, but it's called tkinter. And the problem with the graphical user interfaces to Python is that there are many of them, and no particular one is a leader. And uh, uh, what really happens with Python is that people build these console-based interfaces for users, or they completely jump over these graphical user interfaces for Python programming that run on the desktop, and they jump right to web applications. Okay, so we're going to stop before we get to this file dialog. You're certainly welcome to cover it, and you can ask me questions, but it's not something we're going to be using in the course. And I believe that runs us right to the end. So that's the end of part 2 of chapter 5 lecture. I'm going to say bye until next time. Bye bye.